Hi, welcome to my video on finding the parts of the hyperbola and graphing it, given the general form of an equation. So we have an equation which is in the general form because it's x squared, x, y constant. And we have x squared, y squared, and notice the coefficients of x squared and y squared are 1 is plus and 1 is minus, so we have a hyperbola. Let's group the x's, group the y's, and move the constant, which is 161, to the right, make a positive. Remove the 16 out by factoring, so it's x squared plus 4x. And remove the negative 9 out by factoring. So we're getting ready to complete the square. Half of 4 is 2, 2 squared is 4, 16 times 4 is 64. Half of 6 is 3, 3 squared is 9. Negative 9 times 9 is negative 81. And so that makes it perfect square trinomial is factorable. X, square root of x squared is x. Half of plus 4 is a plus 2. And we got a y squared, which is square root of the y. Half of plus 6 is plus 3 squared. And this adds up to be 144. So we divide by 144. And this 16 into 144 goes 9, so we get x plus 2 squared over 9. Subtract. 9 to 144 goes 16, so we get a y plus 3 squared over 16. And 144 divided by 144 is 1. So we have the standard form. So the center is the opposite of 2, which is negative 2. The opposite of 3, which is negative 3. A squared is with the x. B squared is with the y underneath. A is plus or minus the square root of 9 is 3. B is square root of 16, which is plus or minus 4. So the vertices, because this is plus, this has the transverse axis of the x if intercept is the x because it's positive. The negative one will not. It will not cut the, in this case, the vertical. So the vertices, and it's easy if you take the center, which is negative 2, negative 3, x is negative 2, y is negative 3 here. And look at, and it's horizontal, so you're adding on the 3 and taking off the 3 because it's going horizontal. So we add on 3, we'll go to here. And we take away 3, so we go right to here. So if you take the negative 2 and you add 3, and you take the negative 2 and you subtract 3, that gives you 1, negative 3, and it gives you negative 5, negative 3. So I did the same thing here, but it's easier to see it here when you add the 3 and subtract the 3. So this is V1 and V2. So let's call this one V1 and V2. And the conjugate vertices this is on the horizontal, because the vertices are on the horizontal axis, which is in this case the x, so the conjugate axis is on the y. So we take the y, is add and subtract 4. So we take here, this center, and you go up 4, 1, 2, 3, 4, you hit here. You go down 4, you go 1, 2, 3, 4, right to here. So this is conjugate vertex. So if we call this conjugate vertex 1 and conjugate vertex 2, so let's find those. Just show you again. So we take the x and we add the 4 onto the y, and we take the x, and because we're going up and down, we subtract the 4 from the y. So this gives us negative 2, 1, and this gives us negative 2, negative 7. So when this is the CV1, this is CV2. So we went up 4 and down 4 to pick up these. I'm just showing you here, but it's easier to see when you do it in the graph. The foci are on the horizontal because that's the axis of intercept. But before we do that, we got to go c squared is a squared plus b squared. And a squared is 9. B squared is 16. 9 is 16. That means c squared is 25. C is plus or minus 5. So the foci are on the horizontal. So we take the center and we add on 5. So that's 1, 2, 3, 4, 5 right there. And we take the center and we subtract 5. 1, 2, 3, 4, 5 right there. So that gives us, this is foci 1, and this is foci 2. So what we did, we take the center and we add on 5. And we take the center and we subtract 5 from the x. So that gives us 3, negative 3. And this gives us negative 7, negative 3. So this is F1, this is F2. So 3, negative 3 is right there. And a negative 7, negative 3 is right there. And we should look at the foci, or sorry, we should look at the asymptotes, because the asymptotes helps us to set up the corners of the rectangular box and helps us to graph the where the where the hyperbola is going to go to. So y minus k plus or minus b over a x minus h. So we got a y is negative 3, so it's a y plus 3. B over a, so it's a 4 over the 3. And the x is negative 2, so it's an x plus 2. And notice that these, y plus 3, y plus 3. X plus 2, x plus 2. And so there's 2 of them. One is positive, and the other one is negative. So let's graph the positive one. Here's the center. The center is negative 2, negative 3, negative 2, negative 3. Slope is rise 4, 1, 3. Rise 4, 1, 2, 3, 4, 1, 3. 1, 2, 3. And the other way is, keep on this line, you can go down 4, right 3, right there. So let's draw that asymptote, because the asymptote makes the drawing of the hyperbola much. Going to the center, going to those corners. And we had another one, which is same point, only it's going down 4, right 3, or up 4, left 3. So we can go down from the center, down 4, right 3, right here. Or we can go up 4, left 3, right here. So we draw that asymptote. Again, one is plus and one is minus. And there they are. Let's see, line them up. So the positive one is right here. So it's y plus 3 is 4 over 3x plus 2. And this is the negative one, y plus 3, negative 4 over 3x plus 2. There they are. Now, let's set up the corners. The corners of the box, some people set up the rectangular box, and again, the rectangular box, like the asymptotes, are broken. They're not, they help set up the graph, but they're not the graph. So the graph is, it goes through the vertices and goes out, and it keeps, so the further that x goes to infinity, this gets closer and closer to this asymptote. And the same here. And there's another one going through this vertex, doing this. Here and here. Like 2 boomerangs. So that now, and PF1 minus PF2, in this case is horizontal, so it's a 2A. And A is 3, so that makes it 6. That means the distance between the vertices is 6. Let's see, 3 and 3. That's plus 3, that's a minus 3, so there's 6 between the vertices. Perfect. And notice, again, it's horizontal because the x is positive. the vertices and the foci are on the horizontal, and the co-vertices are on the vertical. And the asymptotes, and this is in the point. Now you can multiply this out and get the equation in what we call the slope y-intercept form, but in this case it's better to leave it in the point slope form. So that's using my general form of equation, change it to standard, and finding all the parts of the hyperbola. If you like my video, click on the like button, click on the subscribe button. If you want to subscribe to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you. Which is, notice Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.